Question, can we get SkySight ourselves? Is it free or do we have to pay for it?
You have to pay for it.
Okay. How much is it?
I knew you were going to ask how much it is.
I can just find it online here.
Yeah, you find it online. I think it's like 80, 90 bucks a year.
Okay.
Yeah, maybe it's 10 bucks a month or 90 bucks a year. So I don't remember. And of course, it's always subject to change. So
Right.
Go ahead and look at that. So at any rate, what we're going to do here tonight is we're going to talk about how the wind can really change rapidly at Boulder Airport, and why the Boulder Airport's really tricky place to fly gliders. So we're going to look at some of the tools that we use to forecast that wind and talk about why it happens this way, and I want to say what to expect. You can expect one thing, but don't fly what you expect. Fly what you find, because in Boulder it may be very different. So let me do a share screen here. Okay, so we're going to go to SkySight first. Do you all see what we're looking at here on SkySight? Good.
Yeah, I got you.
So the Boulder Airport.
Is that Oliver, right? Oh, do you know this guy?
Oh, what's up, Oliver?
No way! What's going on? How you doing, Clyde? What's your affiliation to Jacob?
Jacob's a good buddy of mine. He goes to Cornerstone with me.
Nice, that's sick. How you been?
I don't mean to intercede.
No worries.
Clyde was sitting here, and I said maybe he'd be interested. So,
well,
you've got
another
that student. This is Armand, the flight instructor.
Yeah, are you a pilot also?
I am not, but I know quite a few pilots, so I have some secondhand knowledge.
Okay. Well, we're going to go
math guy.
Yeah, we're going to go over what happens here with winds in Boulder. And as you know, we're pretty close to the Continental Divide, 20 miles or so to the Continental Divide, and so we get some pretty strange winds that come screaming down that lee side of the mountain. So this particular frame here shows 8 o'clock tomorrow morning, and this is a forecast, of course. So forecast for 8 o'clock tomorrow morning. And this is surface winds. You can see over here, I've got surface winds. So what it's showing is basically no wind right over the airport. This is not unusual, what we find even on days when it's going to be really windy. So there's nothing going on here. If you look over here at where the Continental Divide is, here's Niwot Ridge. So further over here, it's blowing 22 on the surface up high. And that's at 8 o'clock in the morning. So we can look at what happens as the day goes on. So this is going through, you can see the winds still pretty calm here at this time, but it's starting to pick up. Okay, so here we are now at 11:30. This is just before it's showing a change. So you can see the wind, it's showing this wind barb right here about 3 knots out of the southeast. And the way you read these wind barbs is like this one's showing west. This one's showing kind of northwest. These are showing right out of the west. And here, this one is showing east. So the Boulder Airport at 11:30 is showing it's kind of right in the cusp of being able to change. So then as we go along a little bit further, now we get to 12:30. Now you can see the winds have changed. And now they're out of the west. And here's like at 11 knots at the Boulder Reservoir out of the west. And that's on the surface. So, and then of course, as the day goes on, and you can see these high winds are kind of drifting now out over the foothills, and it's really starting to affect this area. If we go higher up, let's go back to 8:30, and we look higher up at the average wind in the what's called in the thermal layer or the boundary layer. And you guys know what we're talking about when we say boundary layer of the wind.
Yeah, it's like where the surface interruptions no longer affect the wind direction and speed.
So the boundary layer is where the surface does affect it. Above the boundary layer, the surface doesn't affect it.
What AGL is that approximately?
It depends on the day. So it's going to be much higher probably in the summer than it is in the winter.
Because
so
of
on a hot day with lots of thermals, the boundary layer is going to be up around 20,000 plus feet in this area. But when you get down, in colder weather like this, it's not going to be anywhere near that high.
Okay.
So, on the top, it's going even faster. So let's take a look at about noon. And we can see that just on average, how fast this is 30 knot winds. So it's really going. The thing to look at, and I want you guys to, even though it's not in the PTS, I want you guys to know it. We talk about the skew T. So let's take a look at the skew T at 8 o'clock, right around the Boulder Airport. Okay. So when you look at the skew T, this red line is the temperature. The green line is the dew point temperature. This blue line over here is the wind speed. So you can see here at 8:30, right on the surface, the wind is almost zero. There's almost no wind. But as you go up in altitude, follow the blue. Now we're at 9 knots, 10 knots, and it goes all the way up here to about 21 knots at 9,000 feet. And it's out of the west. So you see these wind barbs down here. This is showing the real light wind is out of the north. And then when you get up to 9,000 feet, all of a sudden it's blowing like crazy out of the west. As you go further in the day, say we go to 10:30, now we're showing the inversion has ridden. Remember the inversion right here, that little notch right there is the inversion. So the inversion is pretty low. When you get up to 11 o'clock, now the inversion is here. 700 millibars is about 10,000 feet MSL. So we see as we get 10,000 feet and see what's happening to the wind. The wind is showing down here on the surface out of the east. But as you get a little bit higher up, 8,000 feet, it's blowing out of the west. And as you keep going higher, it's going faster and faster. By the time you get to say 1 o'clock in the afternoon, the other thing to notice on a little earlier, see this cloud? So the dew point and the temperature get close together, and that forms a cloud. So now it's getting cloudy. All the wind is out of the west. It's a little lower on the surface, but as you get up there a ways, by the time you get to say 1:30, it's really blowing pretty hard out of the west. It's a cloudy day. And if we look at this, we can see a lot of wind. Now, let's take a look at what that wind does to our thermals. Now, this is a chart or graph that shows how much thermal strength you have versus the shear layer. So when you see a lot of these dots, it's called stippling, and that means the wind is breaking up the thermals, and so it's much harder to thermal because the thermals are getting blown apart. So that's going to make for a difficult day.
So Armin, the thicker dots indicate stronger thermals?
No, it indicates stronger wind, more disruption.
The thicker.
So if we go to, what's that?
The thicker the stippling?
Means the more intense it is, the harder it's going to be. So if we go to say here, down by Lubbock, You see, there's no stippling. So that's not going to be as windy. There's not going to be as much.
So the stippling is tracking with the wind flags on this overlay.
I'm sorry, say again?
The stippling in this case is like, should be corresponding to the flags, the wind flags, right? Kind of.
It depends on the day. It just means that it's going to be very turbulent, and they're going to be busted up.
Wow.
Just indicates the amount of rough air.
I mean, what's funny is like, obviously I learned about the weather, with powered flight, but it's like, this is making me feel like I don't know anything about the weather with gliders,
Well, power pilots, of course, have to learn a lot about weather, but you learn what you need to learn for glider is a very specific subset of weather stuff that you just don't need to know in power flying. We're going to talk about thermals too as we go on here, and what actually causes a thermal, how you get them. Now, the other thing, and one of the things that gets a lot of power pilots, airplane pilots around here is wave. And one of the things that I look at when I see that skew T is I think about wave. So let's go back to like 11 o'clock, and this SkySight shows a three-dimensional wave. So sure enough, see that wave? Here's the Denver area, and here's a big wave over on the lee side of the Rockies. This will be exciting. I mean, if you got into this wave with a glider, you can go up really fast, and you can get above 18,000 really fast too. So you got to be careful. But that's showing, there's a lot of wave, and wave is a whole special lesson. This is one of the things that does grab and surprise a lot of airplane pilots. They don't really know what to expect when they don't know what the signs are, and they find themselves not either in wave itself or in rotor. So all the waves have a rotor, and the rotor is when you're in it, you're in it. The rotor's pretty rough, and the rotors that go with the wave, one side of them is going up and one side of them is going down. So if you get on the upwind side of the wave, you can actually climb in a glider, and then you climb up in the rotor until you can get to this wave part, and then the wave is laminar flow and very smooth and very quiet and very nice. But climbing up to it is sometimes a rough ride. On the downside of that rotor, it's down, on the downwind side, and the descent can be 3,000 to 4,000 feet a minute. So it's pretty exciting, and you want to be able to get away from that downside of that rotor if you get caught in it. And of course, if you're going to fly wave, you're going to go through it. So what actually happens here, and why? Get rid of this. And why the wind changes like it does, and why we, even on let's say we take a gentler day. Monday was a fairly gentle day, right? So let's say Monday at like 12:30. We'll take a look at the surface winds. See, the winds are gentle out of the east, 5 knots out of the east. I think we were flying that day, and that's kind of what we had even at 12:30 or so. So let's take a look at what the skew T looks like in that case. So Boulder right there. Okay, there's our skew T. You can see as we go up in altitude, the wind doesn't change much at all. And until you get right here, and that's where you start to get, it's hard to see, but there's an inversion right there, which means the temperature stops decreasing at the same rate, and then increases a little bit. So what happens is the west wind, you see the wind is out of the west up at this altitude, and then out of the east below this inversion. The inversion's here and the wind changes here. So what happens is the wind comes screaming down over the mountains. It gets to that inversion. It can't penetrate that inversion. So it goes downwind towards Nebraska. But you can't have a vacuum. So eventually it drops and comes back and backflows. And that's why we have this nice gentle east wind. Let's see if it's a little more dramatic. Yeah, maybe it's a little more dramatic at this time. And you can see the change. It's west up here at where the inversion is, which is about 10,000 feet. And then you get down here, 7,000 feet, it's gentle under the east. And I think that's kind of what we saw on Monday when we were thermaling. We couldn't find that there was really much wind at all. It didn't really blow us too far compared to the other.
Yeah. And we were at like 7, 8, 9,000.
Yeah.
Yeah.
Yeah, and it was real gentle wind. I think you remember I asked you which way the wind was blowing, and you kind of had trouble.
I made something. Yeah.
Yeah. You tried to come up with an answer.
Yeah.
The answer, I thought anyway, is, gee, we're not drifting at all.
Yeah, well, I mean, pretty much like we were there for like 20 minutes over the same.
Yeah, we didn't really move very far, so there wasn't much wind.
But typically, is the thermal gonna go with the wind, or is the thermal gonna exist over?
No, the thermal will, go with the wind. So when you're looking for a thermal and you look at a cloud, you want to fly to the upwind side of that cloud.
Right, so that you're in the thermal as long as possible.
Well, the thermal is going to be coming, the thermal comes up and then becomes a cloud. So the thermal cools adiabatically. Are you familiar with that term?
Yeah, it means that the air pressure doesn't change, right?
Yeah. It means there's no energy added or subtracted from that column of air. But as it goes up in the atmosphere, there's less pressure, so it expands. And as it expands, it cools. And as it cools, it gets closer to the dew point. And when you get to the dew point, then you get a cloud. So when we look at clouds and we see a cloud out there and it's a big puffy cloud with, lots of tower, like it's wearing a big, stovepipe hat or something, well, that air is going up. So inside that cloud, the reason that cloud gets that tall top is because the air is going up, which means the air underneath it is going up too. Now, if it goes up too much and gains too much water, then you get a thunderstorm. We call that, blows up into a thunderstorm because all the water creates more thermal. Evaporating the water releases a lot of thermal energy, and that blows it up into a thunderstorm. But anyway, let's worry about Boulder. So when we get these west wind days, let's go over here and look at this. So we can do west wind takeoffs in Boulder. I've done them. I can instruct in them, but I'll tell you, I'm not crazy about flying. Here's what happens when we have a strong west wind or a weak west wind, even. See all these on the west end of our runway, we have this lake. Of course, the lake's usually cooler, so it creates some sink. And then you see all these trees along here. Well, that creates a lot of turbulence. So when a tow plane and a tow package takes off and climbs out along here, you'll see a lot of wing rocking, a lot of up and down. And the other thing that's really tough concerning about the west wind takeoff is there's really not a good land out spot. This area over here, if you're high enough to miss the trees, this is pretty rough in here. There's a lot of prairie dog holes, there's rocks, there's a railroad track right here that's elevated. This would be a really tough place to land out. If you can turn around, this field over here also full of prairie dog holes, and not cultivated, so it's going to be a little rough. And you'd be landing downwind, a strong downwind. So you really want to be on top of your game. You want to be careful. You want to have a reason to really go on a west wind day. And as you can see, as I was trying to point out here using SkySight, when that wind switches from east to west, it switches fast, and then it blows, and it stays blowing west for the rest of, usually stays blowing west for the rest of the day. Sometimes you can get out there early in the morning and you can get a few flights in before, it switches. But if you're out flying and you think it's about to switch, land on 2-6, because you'd be better off landing in a gentle tailwind than in a strong. If you land 8, you might get a gentle headwind, or you're going to get a really harsh tailwind. Where if you land on 2-6, you might get a gentle tailwind, or you might get a really strong headwind. So you're a lot better off landing on 2-6 if you're not sure if the wind is shifted or not. That also means that we can have at pattern altitude a west wind, and on the ground an east wind. So Boulder's a tough place to fly because the winds jump all over the place, including changes in altitude. If we take a look at what the forecast is, this is for the National Weather Service. They're showing tomorrow. They're showing, a slight west wind at 8, 9, 10 o'clock in the morning, and then it's, picking up and getting real gusty. And that stippling that we looked at, that probably has a lot to do with the gusts. The gusts make it really hard to thermal. Our total energy systems tend to confuse gusts with thermals. So your instrument, your variometer goes all over the place, and it's just real hard. So there's not going to be great thermals tomorrow, but even if there were great thermals, they would be very, very difficult to fly because of the way they're going to be all broken up by the gusts. So anyway, that's tomorrow morning. And any questions?
I guess I have one question. Why does the inversion go away as the day goes on? What happens to it?
The ground heats, and then that inversion moves up, and at some point it just blends in with the atmosphere. And I guess the higher it gets, the less the heated ground has to do with it, and the atmosphere stabilizes itself out. I don't know if that's a great explanation, but
Well, I'll Google it after we're done here.
okay.
And then also so no flying tomorrow probably.
Not
not in the afternoon. On Sunday,
yeah.
I think I can fly at like 4 if that works for you.
Yeah.
All right.
Okay.
So we just said.
Okay. So what we're showing Sunday at say 4 o'clock. Did you say 4? Oh, 4.
4, yeah.
Yeah.
16.
Hopefully we can get a tug then. I don't know how late they're going to keep flying, but we'll see. Surface winds. Let's see what the forecast is. All right, so that's showing, here's Boulder. So it's showing 11 knots out of the northwest. So we'll just have to see how things look.
Right, yeah. All right.
But
Well,
Armin, would you want to fly Sunday morning, possibly?
I think I'm already scheduled on Sunday morning.
Okay. Yeah.
I
guess we'll talk tomorrow.
Yeah, I am
But
scheduled.
you're still good for tomorrow to meet up in the morning and see how it goes. Okay.
Yeah, let's go out there and then we'll see how it looks. We'll see what the forecast is, and we'll see how it looks, and we'll see if Mile High is flying and can tow us. And if we can, then let's go. And maybe we can get done before the wicked wind of the west.
Yeah. So with Mile High, like what's usually the process for requesting a tow at a certain time? Like if it's like now, obviously they're not going to answer the phone, but
Right.
What
So
do you-
stop there in the morning, say
okay.
hello, tell them who you are,
Yeah.
and how many toes you're going to want, and when and how how many and when you want
Okay.
toes,
Okay.
and they'll tell you. They've been real good here lately. They know the clubs without a tow plane,
Yeah.
and so they seem to be gearing up to have more tow planes available, which is terrific.
Oh, sweet. Nice. Yeah. Did you have anything else planned for this, Armand?
No, I wanted to make this fairly brief. I mean, we need to do a more intensive weather.
Yeah.
I'm planning one for the YouTube channel, and
Cool.
we need to do like more of a soaring weather one.
Yeah. No, this is really interesting. I mean, it's making me realize like how much I need to learn. So I like it. Yeah, that's
Good.
cool.
All right.
All right. Well,
All right.
see you tomorrow morning. And I'll see you around, Oliver. Nice to meet you.
Yeah, nice to meet you too. Yeah, I'll see you guys later.
Yeah, totally. All right. Bye. Have a good night,
All
guys.
right. See you at the field.
Yeah.